Hi friends, welcome to lecture 85 on our helicopter dynamics course, and today I'm going to discuss about rotor noise or helicopter noise in general. I'm Dr. Ranjan Ganguly. Now helicopter noise can be broadly classified into three types: vortex noise, rotational noise, and blade slap. Now among these three sources of helicopter noise, blade slap is the most problematic, followed by vortex noise, and then followed by rotational noise. Now, I should say that in general, noise is, of course, an important variable, not only for the fact that many people do not want to have a lot of noise surrounding them when helicopters land and take off, but also if helicopters are performing certain missions, they need to be very quiet when they are in the vicinity of their targets. So, the quieter they are, the stealthier they are, the more likely that they can complete their missions, and therefore noise becomes an important problem there. Now, there are also many regulations as far as noise is concerned. So, again, if a helicopter is to land successfully or get permission to land in some city or in the middle of a city, then it better have low level of noise. And so people put various constraints on noise also. So these requirements are there established by different government bodies. So that is why we need to study helicopter noise and we need to know the basic sources of helicopter noise. So again, getting back to the issue, we see that blade slap is the most problematic form of noise, and then there is vortex noise, and then there is rotational noise. So let's look at these three components of noise. So generally we can say that low frequencies propagate through the air, but higher frequencies tend to get attenuated with distance. So that's something to remember, is that lower frequencies actually have the possibility of propagating further through the air. Therefore, at larger distances from the helicopter, blade slap and rotational noise become progressively more important. And most often helicopters are detected on the ground by rotational noise. So when you are walking around somewhere and you hear the typical noise of a helicopter as it is flying, you are most likely to hear a rotational noise, and you can in fact figure out from the noise itself that it's very similar to some blades which are rotating. That's the source of this noise. Now, vortex noise is also called broadband noise, and it is a high frequency swishing sound produced by the rotor. It typically takes place at a frequency of 150 Hz to 1000 Hz, with the peak near 300 to 400 Hz. Now, vortex noise is random in nature and is created as a result of random fluctuations in the forces which are acting on the blade. Now, what are the sources of these random forces? Now, most of the time we have looked at helicopter fluid mechanics, we have looked at the deterministic forces which are acting on the rotor, which are the lift, drag, pitching moment, and so on, generated because of the velocity at the airfoil section. But there are also different phenomena which take place. For example, there is turbulence in the wake, there is the presence of tip vortices, there is vortex shedding from the trailing edge of any rotor blade, there is turbulence in the free stream, and there is boundary layer separation. So these are all situations which are hard to model, but just because they are hard to model does not mean that they do not exist in practice. In fact, they are fairly ubiquitous as far as helicopter flight is concerned, and these are all going to be generators of random forces, and those are going to lead to vortex noise. Now let's look at rotational noise. Rotational noise is a thumping sound at the blade passing frequency and typically takes place at n times the rotation speed. So for a four-bladed rotor, it would be 4 times the rotation speed, and so on. Now, it is purely periodic in nature and results from periodic forces exerted by the blade on the air. And we, of course, all know the genesis of periodic forces is the fact that the velocity on the blade section is itself periodic, and therefore lift, drag, pitching moment, all the forces which act on a helicopter rotor are essentially periodic in nature. So the spectrum of rotational noise consists of discrete lines at n times the rotation speed, and the frequency ranges from below audible to about 150 hertz. So that's the spectrum of the rotational noise. Now, further frequencies are important also because the fundamental frequencies are 10 to 20 hertz for the main rotor. So therefore, we have to consider the n per f and further multiples of this particular frequency. Now also remember that the tail rotor has a higher fundamental frequency, and therefore this is often the primary source of rotational noise, and you will see that many times when stealthy helicopters are designed, the focus is actually on the tail rotor because you want to design the tail rotor such that this source of rotational noise is mitigated. Now let's look at blade slap, the third type of noise. Now blade slap is an extreme case of rotational noise which takes place at the blade passage frequency, and it can be considered to be a sharp cracking or slapping noise, and it takes place due to periodic impulsive pressure differences. So the disturbance which create blade slap can be caused by phenomena such as dynamic stall, and we have of course seen the genesis of dynamic stall lies in the presence of alpha as a time varying component in all these helicopter problems. So always remember that as far as helicopters are concerned, alpha is time varying all the time, and therefore especially in the torsional direction you have severe levels of unsteadiness, and so you can encounter dynamic stall in many situations, specifically in high speed flight, maneuver flight, and so on. So you would have this blade slap type of noise present, and typically this would occur at a frequency of 20 to 1000 hertz. So these are the primary sources of helicopter noise. Noise prediction is rather difficult. There are comprehensive theories on this. So acoustics itself is a vast discipline as far as helicopters are concerned. The source of the acoustics here, or the acoustic noise here, is essentially the fluid mechanics. So we need to study the fluid mechanics in detail to figure out the various aspects of rotational noise, blade slap, as well as vortex noise. Especially vortex noise and blade slap would require good levels of fluid mechanics, which would, for example, require use of sophisticated theories including computational modeling of the entire flow field and so on. So that was a brief introduction to helicopter noise. Like I mentioned, this is a vast domain, and if you are interested in this, this is certainly a very good area for research because there is a lot of work to be done here, not only in terms of predicting helicopter noise, but also in terms of removing or reducing helicopter noise. Again, various active control strategies could be used here. So you could use different kind of forcings on the blade, such as trailing edge flap and so on, which if used at particularly good frequencies can help to wipe out some of the forces which actually cause the noise to be present. So that's an active area of research and one can look into it. So I will end this lecture here and I will see you in my next video. See you then.